Hi everybody, welcome to the third episode of SalimZ Learning Simplified. Today, a continuation of the previous episodes, we will be focusing our discussion on a small topic, that is how to learn definitions, how to memorize large definitions in a simple way. Yes, let's go to that method. Come on everybody, let us dive in. So guys, never try to by heart a definition. That is the biggest mistake most of us doing. We say it, we read again. Rote memorization methods we use so that finally after hundreds of times reading, we will recollect the definition just without knowing what is the real meaning of it and just put it on the paper and somehow get the mark. This method called rote memorization or mugging up is entirely a flop for any kinds of studies, whether it is math or science or social or any subject you learn. So then what is the method? What is the real method which you have to focus on so that you catch the definition which will stay with you for long? We can divide our methods into three parts. In three simple steps, we are going to understand how to recollect our definition for long. Step number one, read each and every part of the definition thoroughly, sincerely, by comprehending the meaning. While you read like that, you are supposed to catch your eyes on the most important and key words in the definition. So, sincerely, by keeping your eye on the keywords, read the definition. Step 2, once you read the definition, you are easy to understand which are the parts the definition is speaking to us. So, just fragment the definition into pieces. Cut the definition into pieces. That's called fragmentation. Once you fragmented the definition into pieces, you can arrange them one after the other, the parts of the definition. Step 3, that is the most important step of learning the definition, and that is the heart of our today's discussion, and that is remembering the definition by using any of the two methods. One, the formula method, and two, the photographic method. Guys, remember, these all are scientifically proved. Okay, so never just hear like this and throw. Work it out, and I'm sure if you follow, you are going to do wonders. Come on, let's all get into the method number 1. So guys, in formula method, what we basically do, we just convert the things that we have to learn or the definition that we have to focus on into a formula. After we have already cut that definition into pieces, no, arrange these pieces into a formula and try to recollect them. In physics, it is so simple. Why? Because most of the thing already comes in the form of a formula. But in other subjects, when you don't have a formula, you have to cut the definition to pieces and make them into a formula accordingly, whatever you like. You can create your own formula. And then how formulas make us define quicker. Remember, the method what I'm going to discuss is especially important in physics. Okay, from the chapter electricity, potential difference. You know the potential difference, if we take the formula, it says V equal to W divided by Q. Okay, so what is W? W is equal to work done, and Q is charge. Okay, so let's go ahead for making the definition of potential difference from the formula. Work done, charge, potential difference. Connect them. We got the formula. Work done to move. Okay, this is the pen is the charge. I want to move it. Okay, so to move it, in order to move it, I have to do a work on it, some push or something. So the work done to move a charge from one point to another. Whatever we move, it moves from one point to another. So we got a what statement from this one. Work done to move a charge from one point to another is called potential difference. The definition is clear. Work done to move a charge from one point to another is called potential difference. So by the way, what is the definition for 1 volt? Okay, if the question is 1 volt, we can go for 1 work done unit is joule and charge unit is coulomb. Now you know how to create it. Come on guys, let's go ahead. What is 1 volt of potential difference? Define 1 volt of potential difference. So let's go with right hand side. When 1 joule of work is done, you understand the connection numerator to numerator. When 1 joule of work is done to move a charge of 1 coulomb. Okay, you saw the pattern going from there and coming back like this. When 1 joule of work is done to move a charge of 1 coulomb from one point to another, that is already there because charge moves from one point to another. Let's repeat. When 1 joule of work is done to move a charge of 1 coulomb from one point to another, comma, the potential difference across the conductor is 1 volt. I used the word across. What is the reason? It's like bridge is built across the river. So same way, potential difference is across two things. Potential difference happens between 2 points. So the word we have to use to connect here is across. So let's continue. When 1 joule of work is done to move a charge of 1 coulomb from one point to another, comma, the potential difference across the conductor is 1 volt. Now you write your definitions like this. From the formulas, try to create your definitions. You will surely understand that you can masterize definitions. So guys, let us see how we can draw pictures in order to learn definitions. Let me take one example from physics again. Resistivity. The first definition is resistivity. The definition says like this: a resistance offered by a metal cube of dimensions 1 meter when electricity flows perpendicularly through its opposite phases. That is the definition. I repeat, a resistance offered by a metal cube of dimensions 1 meter when electricity flows perpendicularly through its opposite phases. Now, once you understood the definition, you have fragmented it. Resistance offered by a metal cube. So you need a metal cube of dimensions 1 meter. Here the cube must have the dimension length, breadth and height 1 meter, comma, when electricity passes perpendicularly 90-degree angle perpendicularly through its opposite phases, to the two opposite sides. When electricity passes perpendicularly, this cube gives a resistance, and that is called resistivity of that particular metal. So let us, after splitting our definition, now what is our question? Drawing a diagram. How to remember it in a very simple way. Here we go. The definition says resistance offered by a metal cube. So don't hesitate. Draw a metal cube. Okay. Metal cube is ready. Of dimensions 1 meter. So I am preparing the dimensions. 1 meter length, thickness, breadth, comma, when current flows perpendicular. Current flows means I need to connect what? A pair of wire to pass current through this cube. When current flows perpendicular through its opposite phases, so identify the opposite phases. So imagine I take this as one phase, this is its opposite phase. Okay, now let me make current flow through its opposite phases. How is it? Here we go. Let us draw a wire like this, and the wire coming out, wire entering at a point A and wire exiting at point B, and this wire, suppose it is connected with right angle toward this particular side, the face. Now it is perpendicularly passing through. Now the diagram is ready. Let us create our definition. So what is resistivity? Resistivity is the resistance offered by this metal cube. We already drew the cube. So once this diagram is drawn, it will stay in your brain, and I'm sure if you revise once or twice, it will stay there forever. So the resistance offered by a metal cube of dimensions 1 meter, comma, in the English statement, in the language statement, we need the comma there, a small pause. Resistance offered, resistivity is defined as the resistance offered by a metal cube of dimensions 1 meter, comma, when this is current, no, when current passes 90-degree angle, you can see there, when current passes perpendicularly from here to here, perpendicularly through its opposite faces. So talk about the cube, talk about the 90-degree what current passing wires and the opposite faces, and connect all. Let's go. Resistance offered by a metal cube of dimensions 1 meter, comma, when current passes perpendicularly through its opposite faces is called resistivity. That is photographic memory. Once you get your definition, draw your picture and try to recollect. It will stay there forever. Here let's take yet another example from physics, which is definition from the chapter light. Define the principal focus of a concave mirror. Define the principal focus of a concave mirror. So here we draw a concave mirror, and this is the non-reflecting surface, and as you all know, this point is called the pole, and you know the center of this circle is going to be what? Center of curvature, and in between halfway is what? The principal focus. Now how do I define principal focus? In a very simple way. Very simple way. You are asked a question, define principal focus. Principal focus is the midway between center of curvature and pole of a principal, pole of a concave mirror. But that is not what the definition I am going to give you. That is a common definition for everybody. But how do we create a legendary definition which stands separate from others? Let us get into that. So there is a rule in a concave mirror that this particular color I used is for showing a ray of light, okay, and this line I drew is a ray of light. You got it? And that ray of light, what is special about this ray of light? When we look into this particular blue line at the bottom, which is called principal axis, okay, so this ray of light is actually going parallel to whom? The principal axis. So what is the first point we got? A ray of light passing parallel to the principal axis of whose axis? Of a concave mirror. So we got half of the definition. What is it? Come on guys, let's go. A ray of light passing parallel to the principal axis of a concave mirror undergoes reflection. Like, let's go for the second half. After falling here, it should undergo reflection. No, it reflects and passes through what? This point. That particular point is called principal focus. That's what we are going to define. So here we go. First part once more. A ray of light passing parallel to the, repeat, follow my fingertips from this tip till here you go. That is called a ray of light. Then say what are the adjectives of passing parallel to the principal axis, whose? Of a concave mirror. Connect everything. A ray of light passing parallel to the principal axis of a concave mirror gets reflected. Okay, after falling here it gets reflected. Okay, mirror will reflect. So a ray of light passing parallel to the principal axis of a concave mirror gets reflected, and the reflected ray, let us catch the second part. Okay, and the reflected ray means from this tip of my finger till here, and the reflected ray cuts the principal axis, isn't it? While it is passing, it cuts the principal axis at this particular point. So and the reflected ray cuts the principal axis at a point exactly halfway between the pole and center of curvature. Am I right? This is exactly halfway. So what is second part? And the reflected ray cuts the principal axis at a point exactly midway between center of curvature and pole, and that point is called principal focus. Before we told it's the what? It is actually the midway between this only, but now the legendary definition comes. What is it? Let us make the definition finally. A ray of light passing parallel to the principal axis of a concave mirror will get reflected, and the reflected ray cuts the principal axis at a point exactly halfway between the center of curvature and pole, called principal focus. This is how we can remember definitions, drawing diagrams. Sometimes some pictures will certainly make us remember things like depth. So what is Ohm's law? What is Ohm's law? In physics, Ohm's law is there. What is Ohm's law? A simple definition for Ohm's law goes like this. Ohm's law states that V is always directly proportional to I. Okay, V is directly proportional to I provided temperature remains constant. So this is the simplest way to recollect Ohm's law. By the way, this is the formula method. What is Ohm's law? Potential difference across a conductor is always directly proportional to the current flowing through it, provided temperature remains constant. Finished. No need of learning all the huge diagrams or huge sentences. So what is it? Potential difference across a conductor is always directly proportional to the current flowing through it, provided temperature remains constant. When we work out this one, we finally come into the formula V is equal to Ri, where R is the constant called resistance. So now when we connect these three things, we come into a conclusion like, you can recollect them in a very simple way. Draw a pyramid in the given formula. Who is, suppose we write this formula as I equal to V by R. Okay, whoever is there as a formula having a fraction, imagine you have a formula as a fraction, put that numerator on the top. Imagine the formula doesn't have fraction, rather one number is equal to the product of two numbers R and I. If it is not fraction, that two numbers you put at the bottom. If it is fraction, V, okay, at the top. If it is this way, R and I, they are supposed to be at the bottom. Both the way it is working. Now we got the formula. What is it? R is equal to V by I equal to V by R, V equal to Ri. So that is the three major formulas, and that is called Ohm's law, isn't it? Now, what is the diagram? What is actually Ohm's law? What is actually Ohm's law? Understanding it is very important. That level understanding comes only if you clearly get the topic. What is it? The law states what? When current flows, somebody is there to resist the flow, and who is that? Resistance, isn't it? And if resistance is trying to block it, voltage or the potential on the side is like kicking it, go. Voltage is pressurizing, current, go. Current is really struggling to travel, and resistance is telling, no, don't go, stop there. So beautiful picture we can create for that. Here we go for Ohm's law. Here is a wire, and the wire is tied by somebody, and he is holding on it so tightly and pulling and tightening this part. Okay, let us go for a second person. He is trying to pass through this wire this way, and here we have a third person. He is standing there and kicking the person go through this wire. Okay, so let us get the concept. This person kicking and compelling to pass through the wire, his name is potential difference, and the one really passing is the current, and the one trying to stop the movement of the current is called a resistance. This is the concept explained in Ohm's law. This way pictures will make us recollect most of the things that you are struggling to study. So guys, before concluding, remember, these are some examples which I took from science and explained to you, but this is applicable even in mathematics, social science, and now step by step, series by series, we are covering how to simplify your learning. Like the tagline I have written in the logo, work less and score high. You don't have to work so tough and hard, but remember, work smart. The more smarter you work, the less time you need to understand the concept and learn. So that's all for today. And guys, if you like the video, kindly comment and do not forget to press the subscribe button. And if you have not seen the previous episodes, it will be a wonderful idea clicking these cards so that you can watch those episodes explaining various topics. and keep the bell icon pressed. See you in the next episode. Take care. Bye.